Hi guys, today we'll be looking at the factory design pattern. It's a pattern that provides an interface for creating objects in a superclass, but allows subclasses to alter the type of object that will be created. It's particularly useful when the exact type of the object to be created isn't known until runtime. So we have, in this situation here, you have a class. That class extends its functionalities to other classes. Other classes can have unique implementations that are specific to their needs, but the base class or the superclass has a generic implementation that other subclasses extending its functionality would have to implement to function properly. So that's the concept of the factory design pattern. So it has some key concepts that we'll be talking about here. So it has the factory method as one of its key concepts. It defines the method for creating the objects which subclasses can override to instantiate different types of objects. So with one method, you're able to instantiate whichever subclass you need to use. There's also the product, which is the object being created by the factory method. There's also the creator, the class containing the factory method. Some of the benefits of the factory design pattern includes decoupling. So the code that creates the object from the code that uses the object, they are separate. It reduces the dependencies and promotes code reuse. So you don't have to start instantiating new objects everywhere. With one factory method, you can decide which subclass you want to instantiate. We're going to be seeing all of that code very soon. So there's also the single responsibility principle because the factory method encapsulates the code for creating all the subclasses, or rather instantiating the subclasses. So you don't have different parts of your code where different classes are instantiated. One factory method is instantiating every class available. There's also scalability, so it makes it easy to introduce new products without changing the code that uses the factory. So you can introduce new products. Maybe we're going to be using the vehicle example. So if you just have cars and trucks to start with, that works. If you add buses or rail, what was it called? The rail tracks or trains rather, that works perfectly also. So let's deep dive and get to understand what the factory design pattern is and how to use it in our code. So it makes things a lot easier for us and makes our code clean. So let's come here and open the terminal. So I'm going to initialize a new Node.js project, npm init-y. That does that really quick. We can come to the root of the project and create a new file, a main.js file. Then we're also going to have a vehicle factory file. So I can come to the package.json here and change the main entry of this project, call it main.js. Cool. So I can come to the factory vehicle or vehicle factory file. So here we're going to have a base class or a super class. We'll call it vehicle. And we can have a method, call it a start method. So every vehicle has a start. So let's just throw a new error here. What would that error be? We can say method start must be implemented. Beautiful. So we have our base class or our super class or our interface defined. Now we're going to have subclasses that we want to extend this functionality to. So we're going to say we have a class, a calc, that extends the vehicle class. So for it to extend this vehicle class completely, it has to also implement the start method or start function. So we can call this start, and we can say return car engine has started. Cool. So we can also have other type of vehicles like trucks. So truck also extends the vehicle superclass. So since he extends that, he has to also have implement the start function. So we can say return truck engine has started. Beautiful. So we see we defined the implementations for different types of vehicles. What next we're going to do is we're going to define factory class. So like I said, one of the key concepts is the factory method, which defines the method for creating the object. So we're going to be defining our factory class here. So call it vehicle factory. So our vehicle factory will have a static method called create vehicle. That create vehicle takes a type. So we want to define or how this vehicle factory would know what type of vehicle to instantiate is using this type here. So we can say, let's have a switch here. We have a switch on the type. So you can say case. So if the case is a car, then return new car. If the case is a truck, return, I think I'm supposed to have this here, yeah. Okay, return new truck. So if we don't have that, we can just return or throw new error. Say unable to create vehicle. Beautiful. Oh, we're missing out something here. Okay. Yeah, so we can have all of this inside here. Yeah, beautiful. Yeah, so we can just export this out of this file. Module.export is the vehicle factory. Yeah, beautiful. So let's come to our main.js file and say const vehicle factory. Let's import that. From our vehicle factory here. So let's create a car. At runtime, create a car. So we can say const car is equal to vehicle factory dot create vehicle. Now the reason we're able to access this create vehicle method or function is because we made it static. So whenever a new vehicle is instantiated, a new vehicle factory is instantiated, like we did here, what happens is we can call a method on it without creating an instance of it. So create vehicle. It takes in a type car. It returns a string, so we can just console log that string. Console log, you can say car, or rather it creates a car object, and we have the start function on this car object. So let's also create a truck. So we have const truck. So we have a single factory method responsible for creating all our subclasses. So we have a truck. See how clean this is. Console.log, you can say truck.start. Yeah, beautiful. Let's do node main.js. Yeah, that's as easy as it gets. So car engine has started, truck engine has started. So you see just a single factory creates whether the car or the truck subclass. So you don't have to instantiate, come here and create new instances of the subclass you want to work with. Just this factory handles that for you. So it makes it a lot cleaner and it follows the single responsibility principle, most important. And this is really cool. This is really cool. Also exposes you to stuff like principles like the open and close principle. You see, we didn't have to come to the vehicle class and run and instantiate it here and add new methods for starting cars, starting trucks. Just one single base class or interface was inherited or extended by two other classes, and a factory method was used to decide which of the subclasses to be instantiated at runtime. So you see how cool this is. So you can add buses, you can add more subclasses to extend the vehicle class. You can also add more methods that are specific to the car, um, um, the car object here. So let's come to the vehicle factory here and look at it. So we can add new methods here that are just specific to the car class that are not implemented by the truck class. That's the beauty about using the factory design pattern. It makes it look a lot cleaner and works really good. So that'll be all for now. Thanks.